I'm Jim Fox, Regulator Product Specialist for Zeagle Systems. What you are about to see is a seminar concentrating on the maintenance and repair of the Zeagle DS4, 50D, and Flathead 6 first stages, and the ZX second stage common to all of these models. We'll cover the disassembly, inspection, reassembly, and stage testing of these models. If you are viewing this video in a formal Zeagle service seminar, you will have loosely assembled regulators in front of you, and some provided tools. Various operations, such as lubrication and torquing parts, will be covered in this video, but should not be done on the loosely assembled class regulators. Because the video follows the service manual closely, we recommend using the manual either for instructions during an actual overhaul or for reference purposes during a service seminar. Now let's begin with the first stages of this dynamic regulator series from Zeagle. Zeagle designers have enhanced and added to the features which made the older style Zeagle regulators some of the most popular regulators in North America. Experienced technicians will quickly recognize that Zeagle has made all of these improvements while maintaining a very similar set of service operations. Those procedures that do vary will be explained in detail in this video. All of the new Zeagle regulators are designed and built to exceed the requirements of the U.S. Navy A-Class and European EN 250 certifications. They also have a totally environmentally sealed first stage that results in great durability and resistance to freezing and cold water diving conditions. However, they do have other features that make them unique. The DS4 first stage is a light, compact, low-profile unit with few moving parts. It features 2 high-pressure ports and 4 pre-positioned low-pressure ports. The 50D first stage adds a 360-degree LP port swivel, making it easy to set up today's complex hose configurations. The top-of-the-line Flathead 6 is another low-profile design with the LP ports perfectly located to afford the best hose routing positions with no moving swivel. The inner flow chamber has been repositioned and designed to eliminate the complex flow-limiting air passages found in older designs. This improvement in flow efficiency results in a significant increase in flow capacity without resulting to awkward, stiff, oversized half-inch ports that limit the diver's choice of hose configurations in old-style scuba regulators. In the new Flathead 6, the inlet of all LP hoses is less than 1/8 of an inch from the internal HP valve. This results in tremendous flow capacity. The Zeagle ZX second stage has been reduced in size to make clearing easier, and a new large oval exhaust valve keeps the second stage interior drier during use. The interior of the second stage is accessible without special tools, making inspection and light cleaning of the second stage easier and quicker for the dive store. A new advanced polymer seat material makes the second stage more durable and resistant to heat transfer. This new feature contributes to the second stage's high resistance to the effects of cold water diving. The familiar breathing effort, adjusting knob, and venturi adjustment lever make the ZX second stage extremely adaptable over a wide range of diving conditions. Zeagle publishes maintenance guides for current and past Zeagle regulators and valves. These guides are available to authorized Zeagle dealers through their distributors. Each section covers a specific model, and the guides are continuously updated with new sections as they are needed. Zeagle has added enhanced technical resources for Zeagle dealers and their technical staff. There are CD-ROM libraries and technical websites available for downloading the latest in service information.
Scroll down a little bit.
A feature of the Zeagle regulator line is its serviceability without elaborate, expensive tools. The tools shown here are all that are needed to service the first stage. A clean, well-lit bench space, a soft-jawed bench vise, that's a bench vise with rubber, plastic, aluminum, or plastic jaw inserts, a 1/4-inch Allen wrench, that's part number 3470104, a 3/16 inch Allen wrench, part number 3470316, a 5/32 Allen wrench, part number 3470532, a 6 or 8 inch good quality adjustable wrench, a 15-inch good quality adjustable wrench, a Zeagle pin spanner, part number 3470001, clean shop rags, an LTI Crystalube 111, that's part number 3470111, and an intermediate pressure testing gauge. Zeagle has recently added 2 new tools which are too new to be included in the service manual, so you will have to write their part numbers down from this video. The first one is a pin spanner wrench that has the correct contour to fit on the hydrostatic end cap of the new Flathead 6. Its part number is 347-0003. The second new tool is a second stage orifice inline adjusting tool. Its part number is 347-0002. Zeagle offers service kits which contain the dynamic parts of the regulator which can wear under normal use. These represent the least number of parts that must be changed during every annual overhaul. There is one simple service kit for all of the first stages covered in this video. The part number is 347-1000. The ZX second stage uses a service kit part number 347-2000. These parts are always changed in an overhaul. Because the first stage kit is used for both the yoke and din versions of the regulators, there will always be 1 or 2 O-rings left over after the overhaul. The technician must inspect the regulator to see if any other parts are worn or damaged to the point that they need to be replaced. It is important to remember that other than kit parts, the warranty covers only parts that have failed due to problems with materials or workmanship. Normal wear is not covered. The regulator in front of you in class is loosely assembled, without the yoke or hoses. We will cover a few preliminary steps before you will need to handle it. Before you begin disassembly of the regulator, test the first and second stages for output pressures and leakage. Pre-testing in this way will help the technician to pinpoint any specific problems requiring repair. Use 6-inch or 8-inch adjustable wrenches to disconnect all hoses from the first stage. Pull back the hose protector from the inlet end of the hose. Inspect the hoses for wear. Pay particular attention to the area where the metal ferrules meet the rubber hose material. Remove and discard the O-rings from each end of the hose. Clean, rinse, and blow dry the interior bore of the hoses. Replace the hoses if necessary. The 3 first stage models covered in this video vary slightly. The minor service procedure differences are covered here. Note, for Flathead 6 and DS4 non-swivel only, clamp the regulator carefully in a soft-jawed vise with the HP balance plug facing up. Position the regulator so that the yoke or din wheel is preventing the regulator from rotating as the HP balance plug is loosened. Use a 1/4 inch Allen wrench to loosen and remove the HP balance plug from the body. Note, this step is for the 50D swivel model only. Clamp the regulator carefully in a soft-jawed vise with the turret bolt facing up. Position the regulator so that the yoke or din wheel is preventing the regulator from rotating as the turret bolt is loosened. Use a 1/4 inch Allen wrench to loosen and remove the turret bolt assembly from the turret. Remove the turret assembly from the body. On all models, the next step is to remove the HP valve and bias spring from the HP balance plug or turret bolt. Put the valve and spring aside for now. Next, the O-rings are removed and discarded. If you are watching this video during a seminar, you can leave the O-rings on for the class regulators as you watch the video. The largest O-ring is easily removed. The medium O-ring requires the careful use of a pick. The smallest O-ring is the most difficult to remove. Extreme care must be taken not to gouge the groove that this O-ring sits in. The best way to remove it is to pierce the O-ring with a sharp pin. Then the O-ring can be lifted out. Do not use a scooping action that would cause the end of the pin to scratch the groove that the O-ring sits in. If this groove is scratched during servicing, then the regulator will have an intermediate pressure creep that can only be fixed by replacing the turret bolt or HP balance plug that this small O-ring sits in. Scratches in this groove can only be created by improper O-ring removal and are not covered by the warranty. Reclamp the regulator carefully in a soft-jawed vise with the clear hydrostatic diaphragm facing up. Position the regulator so that the yoke or din wheel is preventing the regulator from rotating as the diaphragm clamping ring is loosened. If the regulator is a flathead 6, use the pin spanner part number 347-0003 to loosen the end cap. Sometimes the clamping ring stays on the end cap when the end cap is removed. If this happens, use the 347-0003 and the 347-001 pin spanners to get the ring and cap apart. On all other models, the black end cap is removed by hand. Discard the old clear hydrostatic diaphragm. Use a Zeagle pin spanner part number 347-0001 installed in the hole in the diaphragm clamping ring to loosen and remove the diaphragm clamping ring from the body. The heel of the spanner can be cushioned with a piece of plastic like the old diaphragm to help prevent damage to the chrome finish on the clamping ring. Remove the body assembly from the vise. Use a 1/4 inch Allen wrench to remove the spring adjuster from the diaphragm clamping ring. Remove the spring carrier, diaphragm, and lifter from the body. Discard the diaphragm. Warning: never reuse the diaphragm in the first stage. A used diaphragm will not clamp securely as required. A used diaphragm may come loose during use, causing a severe regulator malfunction. This is true with all diaphragm first stages. Use a 3/16 Allen wrench to remove the seat support from the body. Remove the seat O-ring assembly and discard both. Reclamp the body carefully in a soft-jawed bench vise. Use a 10 or 15-inch adjustable wrench to loosen and remove the yoke bolt and spacer. Remove the yoke knob assembly and dust cap from the yoke. Note: if the regulator has a din wheel, use a 1/4 inch Allen wrench to remove the din bolt and din wheel. Remove and discard the inlet filter, the filter O-ring, and the din inlet O-ring if the regulator is din equipped. Use a 5/32 inch Allen wrench to remove all remaining port plugs from the body. Discard the port plug O-rings. Clean all metal parts of the first stage in an ultrasonic cleaner or cleaning solution. See Section 6.3 of the Zeagle Regulator Service Manual for recommendations on cleaning solutions. Remove the O-rings before cleaning any metal parts, since the soft O-ring material will absorb cleaning energy from the ultrasonic cleaner, reducing its effectiveness. If major visible corrosion or deposits exist on parts, use a bristle brush, wooden or plastic stick, to rub the deposits off. Allowing acidic cleaning solutions to do all of the work, if deposits are severe, will result in damage to internal chrome plating, which will make parts even more susceptible to future corrosion. Remove the regulator parts from the cleaning solution. Blow internal passageways dry with clean, dry compressed air. Inspect the diaphragm sealing surface and O-ring grooves for scratches or wear. If the regulator was leaking air because of scratches or wear, replace the parts. If some corrosion deposits persist, carefully wipe them away with a plastic scrubbing cloth. Blow any resulting dust out of the regulator parts. Roll the stem of the lifter along a square edge of a table or similar surface to check the stem for straightness. If the head of the lifter wobbles as the stem is rotated, the lifter must be replaced. The most common cause of lifter stem bending is assembling the regulator in the wrong order. Now we can begin reassembling the first stage. Correct order of assembly is extremely important. The diaphragm end must be assembled before the high-pressure balance plug end. Incorrect assembly order will result in damage to the first stage lifter and seat. If the diaphragm end of the regulator is open for any reason, such as replacing the HP seat, the other end of the regulator, turret or HP balance plug, must be disassembled so that the diaphragm end can be reassembled first. To determine the identity of each O-ring in the first stage service kit, remove them from the bag and use the O-ring identification chart on the front page of the Zeagle Regulator Service Manual. Lay each O-ring over its corresponding picture on the page and read the description. Before installing the new O-rings into the regulator, lightly lubricate the O-rings with Crystalube. The most effective way to lubricate the kit O-rings is to put them in a small plastic bag with a pea-sized amount of Crystalube. Rub the O-rings and grease together in the bag until the O-rings are coated evenly. Try not to wipe the lubrication off the O-rings when assembling them onto the other parts. Install the yoke bolt into the yoke. Install the spacer onto the yoke bolt. Install the new inlet filter and filter O-ring into the yoke bolt. Hand tighten the yoke bolt, and spacer into the body. Note, if the regulator has a DIN connection, install the DIN bolt with a new O-ring, DIN wheel, and spacer into the body as described for the yoke assembly. Place the body carefully into a soft-jawed vise so that the yoke bolt or DIN bolt is facing up. Tighten the yoke bolt with a 10 or 15-inch adjustable wrench, or the DIN bolt with a 1/4-inch Allen wrench. Tighten to 20 to 25 foot-pounds. Reposition the body in the soft-jawed vise until the diaphragm opening faces up. Position the body so that the yoke or DIN wheel will prevent the body from turning as you tighten the parts. Install the lightly lubricated O-ring onto the seat. Install the seat into the body from the diaphragm end. The seat installs with the end with a notch and O-ring groove towards the body. Use a 3/16-inch Allen wrench to install the seat support over the seat. Tighten the seat support until you feel it make full contact with the body. Do not tighten beyond that point. Install the lifter into the seat support. Install the new diaphragm into the body. Warning: never reuse the diaphragm in the first stage. A used diaphragm will not clamp securely as required. A used diaphragm may come loose during use, causing a severe regulator malfunction. This is true with all diaphragm first stages. Failure to heed this warning may result in serious injury or death. Screw the spring adjuster about 2 turns into the diaphragm clamping ring from the outside end of the diaphragm clamping ring. Hold the diaphragm clamping ring in one hand and place the spring into the spring adjuster. Place the spring carrier onto the spring. Bring the diaphragm clamping ring assembly up underneath the body as shown. Engage the threads and tighten the ring by hand as far as possible. Using this method to engage the clamping ring into the body helps keep all of the parts centered as the assembly is tightened. Use the pin spanner wrench, Zeagle part number 3470001, to tighten the diaphragm clamping ring the rest of the way down. Tighten to 25 to 30 foot-pounds, or until the edge of the diaphragm clamping ring and the body meet metal to metal. This is essential to ensure that the diaphragm is securely clamped. Use an old first-stage diaphragm as a cushion under the spanner to prevent marks from being made on the diaphragm clamping ring. Note, the next few steps are for the 50D swivel model only. Non-swivel models will be covered after these steps. Use the lightly lubricated new O-rings from the annual service kit. Install the largest O-ring onto the body. Install the smallest O-ring in the kit into the small end of the turret bolt or HP balance plug. This O-ring sits in a groove, so look very carefully after installing it to see that it is sitting properly. Install the medium O-ring onto the threaded section of the turret bolt. Install the largest O-ring onto the turret bolt. Lightly lubricate the stem of the HP valve. Snap the end of the spring over the ledge of the HP valve. Insert the valve and spring into the turret bolt. Install the turret into the body. Relubricate the clean white thrust washer and install it into the turret. Install the turret bolt and valve assembly onto the end of the regulator. Take care to ensure that the HP valve fits over the stem of the lifter as you install the assembly into the body. Install the 1/4-inch Allen wrench into the turret bolt. To engage the turret bolt smoothly into the body, hold the wrench still while rotating the body as seen here. Tighten to 2 to 3 foot-pounds, or just until you feel the firm metal-to-metal contact stopping the rotation of the parts. The DS4 and Flathead 6 models are done in a similar manner, except that the HP balance plugs are installed into the bodies rather than the turret bolt. The same techniques and torques are used. If you are assembling a class regulator during a seminar, it is finished when you screw the bolt into the body. Seminar students can watch the rest of the video to see the complete assembly of the regulator. Install the dust cap and yoke knob onto the yoke. Note, if the regulator has a DIN bolt and wheel instead of a yoke, install those parts instead. Tighten the DIN bolt to 20 to 25 foot-pounds of torque using a 1/4-inch Allen wrench adapter mounted in a suitable torque wrench. Install new O-rings from the kit onto port plugs and install the port plugs into the appropriate ports. Note, for safety, always test the first stage regulator with at least one second stage installed. The demand valve on the second stage acts as a relief valve in case of a malfunction. Install an intermediate pressure test gauge into one of the low pressure ports of the first stage, and a functional second stage into another low pressure port. Plug any remaining open outlet ports with suitable port plugs. The following test determines the regulator's lockup pressure, that is, the pressure put out by the first stage during a no-flow condition. Attach the regulator to a tank valve giving a source pressure of between 2,700 and 3,500 psi-G. Turn the supply air on slowly while listening for any unusual air leaks. If any are heard, turn the air off immediately and determine the source of the leak. If no leaks are found, watch the intermediate pressure gauge reading rise as you continue turning the air on slowly. It should stop before 145 psi, that's 10 bar, since the intermediate pressure has not yet been set. If the pressure gauge continues to rise above 155 psi, turn the air supply off immediately and inspect the regulator to determine the cause. Depress the purge cover fully and then release it several times to clear particles from the regulator and to work the internal parts into place. To prevent uncontrolled free flows after pushing the purge cover, keep the Venturi control lever on the second stage in the negative position. The pressure range for Zeagle regulators is 130 to 145 psi. That's 9 to 10 bar. Use a 1/4 inch Allen wrench installed into the spring adjuster to change the intermediate pressure. Turn the spring adjuster clockwise in 1/8 turn steps to raise the intermediate pressure, and counterclockwise in 1/8 turn steps to lower it. Always push the purge cover briefly between each adjustment step. Do not push on the diaphragm with the tip of the Allen wrench, or a false, higher reading will occur. After reaching the proper pressure setting, push the purge cover on the second stage again several times and watch how the intermediate pressure reading responds. When the purge cover on the second stage is depressed, the intermediate pressure reading will drop. When the purge cover is released, the pressure should return immediately to the proper lockup pressure and stay there. Let the regulator sit with the tank valve turned on for several minutes. The intermediate pressure reading may rise about 3 psi in the first 3 seconds after lockup, but after that it should not rise more than another 4 psi, that's 0.3 bar, in 5 minutes. If it rises more than 4 psi, refer to the troubleshooting section 6.1 of the service manual. To finish installing the end cap on the first stage, the pressure to the first stage must be left on to position all internal parts properly. It is very important to the regulator's proper function that the end cap is tightened while the regulator is pressurized. With the regulator pressurized, insert the hydro transmitter into the body assembly. Install the new clear hydrostatic diaphragm into the recess in the diaphragm clamping ring over the hydro transmitter. On the flathead 6 only, install the trim ring. Install the end cap onto the diaphragm clamping ring. Use a clean rag to help grasp the end cap. Tighten the end cap firmly. Use enough force so that the end cap cannot be loosened easily by hand. On the flathead 6 only, use the Zeagle pin spanner 347-0001 to tighten the cap snugly. Use an old first stage diaphragm as a cushion under the spanner to prevent marks from being made on the environmental end cap. Push the clear hydrostatic diaphragm briefly with one finger while watching the intermediate pressure gauge. The pressure should rise about 1 psi for every pound of force. For example, a 5 or 10 pound increase in intermediate pressure when the diaphragm is pushed with 5 or 10 pounds. Turn off the supply pressure and depress the purge cover to release the air from the second stage. When the intermediate pressure drops to 0, you should see the clear hydrostatic diaphragm pull into the body assembly. If the regulator is repressurized, the clear diaphragm will push out to the flat position. If, by mistake, the end cap is loosened and then retightened without pressure applied to the first stage, the clear diaphragm will bulge outward when the regulator is under pressure. If this condition exists, repressurize, then loosen and tighten the cap again to let the excess air out of the spring chamber. The first stage is now completely serviced. We will now cover the teardown, reassembly, and testing of the Zeagle second stage. The procedures covered in this part of the video apply to the ZX second stage regulator. This second stage is used as a primary unit with a gray or black purge cover and 30-inch hose, and as an advanced octopus unit, yellow purge cover and 36-inch hose. The serial number for this model always starts with H. The number can be seen by curling back the mouthpiece and looking at the end of the mouth tube. The following tools are required to properly service the Zeagle ZX second stage. 2 good quality 6 or 8 inch, that's 15 or 20 centimeter adjustable wrenches, side cutting pliers, a 3/16 Allen wrench, or a second stage inline adjusting tool with a 3/16 hex, that's Zeagle part number 3470002. A second stage annual service kit, 345-2000, clean shop rags, and Crystalube. Pull the nut cover off the nut. Use the 6-inch or 8-inch adjustable wrenches to loosen the hose nut from the valve tube. Remove the hose assembly from the second stage. Inspect the hose assembly for any cuts or cracks, especially on the hose at the metal ferrules. Remove and discard the O-rings from each end of the hose. Clean, rinse, and blow dry the interior bore of the hose. Replace the hose assembly if any cuts or cracks are found. Remove the mouthpiece by cutting the 2 mouthpiece ties with side cutting pliers. Discard the old mouthpiece ties. Examine the condition of the mouthpiece. Pay particular attention to the area on top just behind where the old ties tightened. This is a prime area for small holes to develop. If the mouthpiece is in good condition, it can be reused. Remove the exhaust tee from the case by pulling it back and off the top edge of the retaining flange on the housing. Note, the exhaust tee can be removed more easily if hot water from a tap is run over and through it for about 1 minute. Before removing the exhaust valve from the housing, bend the valve over as far as it will go from the top, bottom, left, and right sides. If it fails to snap back quickly and does not lie perfectly flat against the housing exhaust grid, the valve should be replaced. If it does snap back satisfactorily, remove it by pulling it out with your fingers. Inspect the sealing edges. If they appear smooth and the locking tab on the nipple is good, the valve can be reused. Unscrew the cover ring from the housing. Remove the diaphragm cover and diaphragm from the housing. Put them aside for now. For future reference, look at the lever at this time. Notice how the pivot end of the lever is held into the valve tube by 2 plastic flanges on the housing. Note this positioning for reassembly. Hold the diaphragm up to a light source. Gently stretch the diaphragm and look for tears or pinholes. If any are found, replace the diaphragm. Loosen and remove the nut from the valve tube. Remove the heatsink from the valve tube. Note, on some models, instead of a metal heatsink, there is a plastic bushing. Turn the spring adjust knob fully counterclockwise until it comes to its stop. Depress the lever fully onto the valve tube. Grasp the tab of the Venturi control lever. While pulling on the Venturi control lever, push the valve tube assembly out of the housing. The valve tube O-ring usually stays in the recess in the housing when the valve tube is removed. Find it and put it aside for now. Remove the Venturi control lever from the valve tube assembly. Turn the spring adjust knob clockwise 1/2 turn. The pin will fall out of the valve tube or can now be easily removed. Turn the spring adjust knob counterclockwise to remove it from the valve tube. The balancing chamber, spring, and piston are removed at this time. They will often fall out if the valve tube is tipped on its end. If the piston still does not come out, a 5/32 inch, that's 4 to 5 millimeter, Allen wrench can be inserted through the male threaded end of the valve tube and through the seat to gently push the piston out. Remove and discard the O-ring from the outside of the valve tube. The lever should not be removed from the valve tube unnecessarily. However, it can be removed from the valve body by carefully springing out one of the feet and pivoting it over the valve tube body. Do not overbend the lever legs. Straighten the legs if they are bent outwards from parallel. Remove and discard the black seating seal from the piston. Remove and discard the very small O-ring from the piston. This can be done by pinching a section of the O-ring out of the groove with the fingernails. Then, flip the O-ring off the end of the piston stem. Leave this O-ring on if you are working with a seminar regulator in class. Do not use sharp metal picks. Metal tools will damage the plastic O-ring groove, which will cause a small continuous leak from the second stage. Use a 3/16" Allen wrench or the Zeagle second stage inline adjusting tool, part number 3470002, to turn the seat counterclockwise enough to fully disengage the threads from the valve tube. After the threads are disengaged, remove the seat from the valve tube by pulling and turning counterclockwise at the same time. The seat will usually come out on the end of the Allen wrench. If it will not come out, it can be pushed out with a soft wooden dowel. However, extreme care must be taken not to damage the seat if it is pushed out. Remove and discard the O-ring from the seat. Rinse all plastic and silicone parts in fresh, warm, soapy water solution. If necessary, because of deposits or corrosion, clean all metal parts of the second stage in an ultrasonic cleaner or cleaning solution. Rinse with clean, warm water and then blow the parts dry with compressed air to remove any sand and dust particles. Inspect the housing for any cracks or nicks. Look particularly closely at the area where the exhaust valve seals and where the heatsink clamps. Replace the housing if any cracks are found. Because of the molding process, there is a harmless knit line in the heatsink clamping area. It can be seen at the 6 o'clock position when holding the housing with the front face vertically. The housing does not need to be replaced if only this knit line is seen. Inspect the sealing surface on the seat, where the seating seat seals, for any nicks or scratches. Replace the seat if any serious defects are found at the sealing area, or if the threads appear worn out. Blow all dust and debris out of the orifice with clean compressed air. During an annual overhaul, all parts included in the annual service kit are replaced no matter what the condition of those parts. Carefully examine all other parts of the second stage for signs of deterioration. Replace those parts too where necessary. To determine the identity of each O-ring in the second stage service kit, remove them from the bag and use the O-ring identification chart on the back page of the service manual. Lay each O-ring over its corresponding picture on the page and read the description. Before installing new O-rings into the regulator, lightly lubricate the O-rings with Crystalube. Install the exhaust valve into the case by inserting the nipple into the square hole from the outside of the case. Reach inside and pull the nipple firmly with the fingers until you hear or feel it click into place. Inspect the exhaust valve to see that it is properly seated. Take care not to get any lubricating grease on the exhaust valve during this procedure. Install the exhaust tee into the case by hooking the tee over the flat part of the flange and then working it over the rest of the flange. This operation is made much easier if the tee is immersed for about 1 minute in hot tap water to soften it temporarily. Install a new O-ring onto the outside of the valve tube. If the lever was removed, carefully refit it into the valve tube. To orient the lever properly, hold the valve tube with the external threads to the right. Turn the valve tube until you can see the hole where the air exits. The lever is inserted so that it leans to the left. Work the lever into the valve tube 1 foot at a time so that the lever legs are spread outwards as little as possible. Insert the new seating seal into the white piston. Install the lubricated small O-ring into the piston tip. Install the spring onto the piston and the balance cylinder onto the piston to make the shuttle valve assembly. So that you can more clearly see the position of the feet of the shuttle valve assembly, during installation in this video, we will mark one of the feet with a black marker. Hold the valve tube assembly in one hand with the aspirator hole facing you and the lever hanging down as shown here. Take the shuttle assembly in the other hand with the L-shaped foot of the lever engagement pad, which we painted black for this demonstration, pointing down as shown. The shuttle assembly is inserted into the valve tube at the end with the raised collar opposite the external threaded end. When the shuttle assembly is inserted into the valve tube, it is important that the L-shaped foot on the piston section engages properly with the lever tabs that extend through the holes in the valve tube. As you insert the shuttle valve assembly into the valve tube, look through the aspirator hole. You will first see the black seal go past the hole, followed by the L-shaped foot. Next, the side vane of the shuttle valve assembly will pass by the hole. This vane must be kept centered in the hole to ensure proper engagement. The black seating seal may hang up on the tabs of the lever. Wiggle the lever to get past those tabs. When the L-shaped feet get to the lever tabs, they will lift the lever upwards as you push the assembly in. Install a new well-lubricated O-ring onto the spring adjuster knob assembly. Insert the spring adjuster knob assembly into the valve tube over the shuttle valve assembly you just installed. Turn the spring adjuster knob assembly clockwise until the O-ring and flange have passed the hole where the pin is installed. Install the pin into the valve tube. Back the spring adjuster knob assembly out counterclockwise until it tightens against the pin, holding it in place. Install the new O-ring onto the Venturi control lever. While holding the tabs in place in the valve tube with 2 fingers, depress the lever and slide the Venturi control lever into place on the valve tube. Install the valve tube assembly into the housing. After assembly, make sure that the pivot end of the lever is held into the valve tube by 2 plastic flanges on the housing, just as they did when you took the housing apart. Install the O-ring over the external threaded end of the valve tube. Remember, do not lubricate this O-ring. Install the heat sink over the external threaded end of the valve tube. Install the nut over the external threaded end of the valve tube. Tighten the nut snugly. That's 1 to 2 foot-pounds with a wrench. Install the new lubricated O-ring onto the seat. Use the 3/16 inch Allen wrench or the second stage inline adjusting tool to install the seat into the valve tube. Tighten the seat clockwise with the Allen wrench or inline tool. It is important that the final adjustment of the seat leaves the lever with just a little, that's 2 to 3 degrees of arc, free movement to allow for the natural wear of the seating seal during use of the regulator. But that point has to be reached in steps. To get close to the correct point, we first have to get the seat close to the seating seal. We begin by turning the seat with the Allen wrench in clockwise while wiggling the tip of the lever back and forth with the tip of the fingers. Stop turning the seat as soon as you feel the slight amount of free play. Then, turn the orifice counterclockwise about 1 turn to just barely pull the seat away from the orifice. Now, try to wiggle the end of the lever up and down with the fingertip. It should firmly spring back to its original position at this time with no free play, since you adjusted the seat out 1 full turn to move it barely away from the seating seal. Finally, we will adjust the seat into its final position. Depress the lever about 1/2 way down while using a 3/16 inch Allen wrench or the second stage inline adjusting tool to turn the seat 1/8 of a turn clockwise. Release the lever after turning the seat and use the fingertip to again test for any free play in the end of the lever. Continue turning the seat and testing the end of the lever until you find the point where you get about 1/8 of an inch free play at the end of the lever. This free play adjustment is important as it allows the seat and the poppet assembly to shift during normal wear of the regulator. If there is not enough free play adjusted into the lever movement, the regulator will have a hissing free flow after just a few days of use. If you are using an inline adjusting tool, install it between the hose and the second stage body. Turn the effort adjusting knob of the regulator all of the way out. That's counterclockwise. Carefully turn the tank air valve on just barely enough to let the air flow through the regulator. You will hear a hiss of air coming from the second stage. Turn the seat clockwise, that's towards the seal. As soon as the seat makes contact with the seal, the air will stop flowing through the second stage. Adjust the seat so that the lever has about 1/8 of an inch loose free play. It is quite common and acceptable for the regulator to hiss air slightly with the adjusting knob in the full out position. This means that the regulator has been set up to inhale very easily. The slight hiss can be stopped by turning the adjusting knob in clockwise about 1/8 of a turn. Now depress the lever a few times while the regulator is pressurized. Each time the lever is released, no air hissing should be heard. Install the diaphragm into the housing so that it sits evenly on the ledge. Install the diaphragm cover ring over the diaphragm. Use the cover ring to position the diaphragm properly into its groove. Install the purge dome into the cover ring. Screw the purge dome and cover ring into the housing. Adjust the purge dome in the cover ring so that the Zeagle logo sits properly when the cover ring is tightened firmly, hand tight. Tighten the hose onto the valve tube with a wrench. Slide the hose nut cover back over the hose connection. Attach the regulator to the water column or water manometer again. It should now read somewhere between 0.7 and 1.2 inches of water column. The adjustment knob on the side of the regulator can be used to change the cracking effort through a wide range. If the diver is testing the regulator or doing a normal dive, the full counterclockwise position will be fine. Many other setup and diagnostic tests can be found in the back of the Zeagle Regulator Service Manual, part number 347-2000. It is a good idea for the technician to take the time to familiarize themselves with these advanced procedures and troubleshooting techniques. To receive replacement parts, if the regulator serviced is under warranty, a couple of further steps are needed. Make a copy of the warranty service sheet found in the back page of the Zeagle Regulator Service Manual. Fill all of the required information out, including the customer's name, address, and serial numbers. If any parts other than those in the kit are being returned, they must be noted on the form in the appropriate area. Staple the kit parts in a small plastic bag to the form. At your convenience, call Zeagle Customer Service and tell them that you want to return parts for replacement. They will issue you an RA number, which you will note on the form. More than one set of parts can be sent back on one RA number, but the number of kits you send must match the number you said you would send when the RA was issued. After the parts are received and inspected, the replacement kits will be sent to you. Parts in the kits are replaced under warranty no matter what their condition. All other parts must have failed due to problems with materials or workmanship to be replaced. Normal wear and tear on parts is not covered. This covers the teardown, reassembly, and setup of the current line of Zeagle regulators. If you have any further questions, ask the Zeagle representative at this seminar or contact Zeagle at the following numbers. I'm Jim Fox, Zeagle Product Specialist. In this video, we will be covering the annual service procedure for the Zeagle BCD Power Inflator, part number 112-1001, and its high flow variation 112-2001. These two inflators are very similar. The only difference is in the inflator hose connection. The standard 112-1001 has a common QD fitting that connects to most inflator hoses on the market. The 112-2001 has a larger high-flow quick disconnect fitting and extension that allows the hose used on the Zeagle Octa Plus to also be used on this inflator. The use of this larger QD fitting gives faster fill times at extreme depths and is desirable in some diving situations. To perform the maintenance covered here, you will need the following: a clean, well-lit bench space, a Zeagle Inflator Service Kit, part number 145-1000, a long-shanked 3/16 inch Allen wrench, a 1/4 inch Allen wrench, a small Phillips screwdriver, a 5/16 inch nut driver, a 1/2 inch wrench, pliers, a pick, a clean lint-free rag, a tube of Loctite 380 thread sealant for ABS plastic, Zeagle part number 347-0380, lubricating compound LTI Crystalube 111, that's Zeagle part number 3470111, a toothbrush or similar small brush, an inflator hose with the proper QD fitting attached to an air supply, and a BCD and tub of water to test for leaks after the servicing is done. An exploded view diagram of the 112-1001 inflator can be found in the Inflator Service Manual, part number 147-2000. Refer to this diagram for a listing of part numbers. This and other Zeagle service manuals are also available on the web for downloading by Zeagle dealers. Because this site is not for the general public, its address changes from time to time. Contact your Zeagle sales representative for the current address of the Zeagle technical website. To begin, remove the two ties holding the inflator onto the corrugated hose by twisting them with pliers. Pull the corrugated hose off the end of the inflator to expose the stainless steel pull cable and pin. Remove the pin with needle nose pliers. Remove the quick disconnect fitting from the body with a 1/2 inch wrench. If the inflator is the high flow 112-2001 model, the extension should be left in the body for the entire procedure unless there is a leak between the body and the extension. Remove and discard the O-ring from the QD fitting. Use a 1/4 inch Allen wrench to loosen the valve insert assembly. Use pliers to pull the valve insert assembly out of the body. Discard the valve insert assembly. Carefully remove and discard the label sticker from the inflate button with a sharp pick. Use the 5/16 inch nut driver to hold the inflate shaft by inserting the nut driver into the opening that the valve insert assembly was removed from. Use a small Phillips screwdriver to remove the screw from the button. Discard the O-ring and the inflate shaft. Insert the long 3/16 inch Allen wrench into the body opposite the dump button until it engages the internal dump valve shaft. Turn the Allen wrench and the button to loosen and remove the dump valve from the dump button. Remove and discard the O-rings from the dump valve and the dump button. When removing the O-ring from the plastic parts, take extreme care not to damage the O-ring grooves. Groove damage will result in leakage that will require replacement of the damaged parts. We will now begin cleaning and inspecting the parts. Clean the parts that can be reused in warm soapy water. Clean any thread adhesive residue from the metal QD fitting threads. Rinse and blow all parts dry. Look closely at plastic parts for wear and cracks. Look particularly closely at the areas under stress from threading and clamping. Discard any part that shows signs of cracking. We will now reassemble the inflator. Open the Zeagle service kit, part number 145-1000. Remove and inspect all parts in the kit. Lubricate all loose kit O-rings with lubricating compound LTI Crystalube 111. It is available from Zeagle as part number 347-0111. Install the O-ring onto the dump valve. Install the O-ring onto the dump button. Lubricate the threads on the dump valve with grease. Place the dump valve onto the end of the long 3/16" Allen wrench. Insert the dump valve into the body through the BC inflator hose end. Install the spring, wide end first, over the dump valve from the dump button end. Turn the spring onto the shaft. Screw the dump valve into the dump button. Stop turning as soon as you feel the shoulders of the two parts meet. Install the smallest O-ring in the kit on the new inflate shaft that also came in the kit. Use the 5/16" nut driver to push the new inflate shaft with its new O-ring into the body. Place the spring washer and inflate button into the recess of the body. Use a small Phillips screwdriver to install the screw through the inflate button into the new inflate shaft. Hold the inflate shaft from turning by using the 5/16" nut driver. Just tighten the screw snugly. Stop turning when you feel the shoulders of the parts meet. Install the new sticker onto the inflate button. Generously lubricate the threads and O-rings in place on the valve insert assembly that came with the service kit. Push the valve insert assembly into the body. Use the 1/4" Allen wrench to tighten the valve insert snugly into the body. Stop turning the insert when you feel the shoulder of the parts meet. Install the new O-ring onto the QD fitting. Note, it is very important that you place a drop of Loctite 380 thread sealant, that's Zeagle part number 347-0380, onto the outer two threads of the QD fitting. This prevents the QD fitting loosening from the body. Install the QD fitting into the body. Tighten the fitting with a 1/2" wrench. Stop turning the fitting when you see and feel the shoulders of the parts meet. Next, the assembled inflator is tested for performance and leaks. Push and release both inflate and deflate buttons. Check for smooth operation. Before hooking the power inflator up to the corrugated BC hose, install it on a pressurized BC inflator hose. Immerse the entire power inflator underwater for at least 5 minutes. Look for leaks. Replace necessary parts if any leaks are found. Install the power inflator onto the corrugated hose of the BCD and to a pressurized inflator hose. Again, check the buttons for proper operation and feel. Fully inflate the BCD and again submerge the power inflator underwater for 5 minutes. Look for leaks. Replace necessary parts if any leaks are found. The Zeagle power inflator has now been serviced and tested. Zeagle recommends that the service procedure described here be done on an annual basis for inflators used under average sport diving conditions. Rental or heavily used gear may require more frequent inspections. Zeagle products are developed and improved with suggestions from important customers like you. Please continue giving us your input so we can continue to develop the entire Zeagle product line to meet and exceed your expectations. Your comments and suggestions can be passed on to us through your Zeagle sales representative or email to us directly at tech@zeagle.com.